Hi everyone, in this video I will teach you how to find the domain of a rational function that has a square root in the numerator. I also have other videos about finding the domain of different functions in my YouTube channel, so please check that out. Okay, let's begin with this first example. So there are two things we need to consider here, the numerator and the denominator at the same time. So what we will do is we will find the domain of the numerator and find the restriction. And by the way, the restriction is that x minus 4 cannot be a negative number. In the denominator, x plus 1 cannot be equal to 0. So we will consider those two things. And what we will do is we will find the intersection of those two, and that will be our domain. So let's begin with the numerator. So to solve this problem, this is how we set it up. First, x minus 4 can be greater than or equal to 0, which means we will add 4 on both sides. That means x is greater than or equal to 4. That's our numerator. Let's have the denominator. So the denominator is x plus 1 cannot be equal to 0, which means we will subtract 1 on both sides. So we cross that out. That means x cannot be equal to negative 1. Now we will consider these two restrictions, okay? And to find the intersection of these two, I think it's better if we have an illustration, or let's draw this number line to locate those numbers that we will include and those numbers that we will exclude. Okay, so this is our number line. Our objective here is to find the intersection of those two. So we have 0 here. This is our negative 1. And this is our negative 4. Okay, so negative 4. Sorry, positive 4. It's positive 4. Now for the first consideration, which is x is greater than positive 4, or greater than or equal to positive 4, first domain, that means we're talking about, okay, we will include that 4 up to, okay, up to positive infinity. Okay, let me just simplify that. Positive 4 to positive infinity. So that's the meaning of that. Okay. Now for the second domain, which is x is not equal to negative 1, which means all real numbers except negative 1. So I will make a circle here. Okay, that means negative 1 is not included. All the numbers on the right side of that are included. All the numbers on the left side of that are included. Now watch for the intersection. Okay, so obviously, okay, let me draw this again. There you go. So obviously the intersection is located here. Okay, that's the intersection. Okay, here is the intersection. So here is the intersection. So let me just emphasize that. Which means that the domain of this function will be this. Okay, so and then let's just convert that into interval notation. It's gonna be, so since that is greater than symbol, we will start with 4. And we will use that symbol. That means inclusive. We will include 4 for the as part of the domain up to positive infinity. Okay, so that's for number 1. Let's go to number 2. Again, let's check the domain for the numerator. So 10 minus 2x is greater than or equal to 0. So we subtract 10 on both sides. This will be negative 2x is greater than or equal to negative 10. And then divided by negative 2. And again, that inequality symbol will switch because we divided a negative number. So that's the domain for the numerator. Let's check the denominator. So the denominator is x squared minus 4. Okay, so it cannot be equal to 0. So we add 4 on both sides. This will be x squared. It's not equal to 4. And then we need to find the square root of both sides. That means x is not equal to positive negative 2. So we have the two domains now. Let's find the intersection. Let's draw this number line again. That 5 or x is less than 5 means, so this is 0, this is negative 2, this is positive 2. Oh, 1, 2, 3, 4, 5. That's number 5. Okay, let's just put the numbers that are part of the problem here. What do we mean by x is less than or equal to 5? So this is the meaning of that. Okay. Now what about x cannot be equal to positive negative 2? So which means I'm going to put a circle here and there. All the numbers in between are included. All the numbers from or greater than positive 2 are included. And all the numbers less than negative 2 are included. And all the numbers between negative 2 and 2 are negative 2 and positive 2 are included. So where is the domain? Where is the intersection? It's right here. Okay, here's the intersection. Okay, but you have to remember we will not include negative 2 and positive 2. So how are we going to convert that into interval notation? So we will start, since it's less than, right? We start with negative infinity. We will start with negative infinity up to negative 2, and we will use this symbol. That means that negative 2 is not included. Union of negative 2 to positive 2. Union of positive 2 up to 5, and that 5 is included, so I will use that symbol. And here is the domain of that function. Okay, let's go to the next example. Again, x plus 5 is greater than or equal to 0. Subtract 5 on both sides, which means that x is greater than or equal to negative 5. And then we got x minus 3 is not equal to 0. We add 3 on both sides. Therefore, x is not equal to 3. So there you go. Those are the two domains. The next step is to figure out where is the intersection. Okay, I always include 0. Positive 3. Then we got negative 5. 1, 2, 3, 4, 5. This is negative 5. Let's begin with the first domain. Negative 5 to positive infinity. Now, the second domain will be all real numbers except that positive 3. So it's clear, right? Here's the intersection. Right here. That's the intersection. So how are we going to convert that into interval notation? So we start with negative 5 up to 3. But that 3 is not included, so we will use that close parenthesis symbol. Union of positive 3 to positive infinity. Okay, let's go to the last example. Okay, here we go. So again, 12 plus 3x is greater than or equal to 0. Okay, so we will subtract 12 on both sides, cross that out. This will be 3x is greater than or equal to negative 12. Okay, so here we are dividing a positive number, so that symbol is not going to change. Negative 4. So that's our first domain. Let's go to find the second domain. X squared minus 16 is not equal to 0. We add 16 on both sides. This will be x squared. It's not equal to 16. Find the square root. X is not equal to 4. Positive 4 and negative 4. Oh, this is interesting. Okay, let's see. Now locate that negative 4. It's here. 3, 2, 1. Here's the 0, and then the positive 4. 1, 2, 3, 4. Here's the positive 4. So x is greater than or equal to negative 4, which means this. Okay, wait. Where is that? There you go. And then the second one, all real numbers except 4 and negative 4. So here's the meaning of that. Okay. Now here we go. Here's the intersection. Okay. Now that means we will not include negative 4. Okay. So that means to convert that into interval notation, we will use this symbol. We will start with negative 4, of course, and use that symbol up to 4. Close that. Union of 4 to positive infinity. There you go. So that's it for this topic, finding the square root of a rational function that has a square root in the numerator. So thank you for watching and have a nice day.